Thank you, Dr. Coates, for that introduction. Yep, and just to make sure, I'm a Penn State grad, but we hire a whole lot of Rolla grads. But yeah, we're a strong proponent of, talks that we've had before about careers in mining, and so, definitely feel free to reach out anytime. So thank you again, Dr. Coates. Thank you to S&T for organizing this. It's a great topic. Dr. Kwame asked me to talk about feasibility studies in general, and then a bit more in the context of critical minerals and REEs. Again, just to be back on, I'm not going to dwell on this, but just wanted to say that I've been fortunate to be involved in what we call public disclosure requirements. Ever since I started, I actually, because of the international aspect of the work we do, I actually started in the Australian JORC code, but then since we've been very active as part of the SEC's SK 1300 requirements as well for reporting. And it's been a great journey, actually. So as we all know, the reason we're all here is understanding that we're at a crossroads in terms of critical minerals and rare earths projects, and how that has become a very crucial security concern for our country. So there's this push with the strategy to enhance the security of supply, and particularly focusing on seeing where we can ramp up domestic production, domestic capacity, domestic mines. So as a result, we are seeing a lot of mines focusing on developing new projects for addressing the shortages we see in critical minerals and REEs. And as part of this is, if you are a mine, as we all know, it takes a lot of money to open up a mine. And so it essentially comes down to financing. Whether it's public or private, at this point in time, it's really goes to demonstrating the feasibility of our project, right? And we've got Pat Eisner who talked about South 32 and how they've come along, pre-feasibility, feasibility, construction, which is your classic life cycle. But again, it takes time and money, as with everything else. And this time around with money, we're talking hundreds of millions approaching billions of dollars now. So it's a fairly significant investment that no single entity is going to take on. Larger companies for sure, South 32s, BHPs, Rios, it's a different perspective. But what we're seeing in the RE space are not the large players yet, but they're still costing a lot of money, and we'll put that in perspective as we go along. The bottom line, though, that last sentence out there, in all mining companies, whether public or private, wherever you're raising your money, you are required, or it is pretty much being required by the financing institutions to demonstrate that feasibility, which is essentially through that series of steps. And we'll talk briefly about that as well. And it's all about being transparent and establishing confidence for those investors in your project. So this is just a quick rundown for those of you who haven't seen a periodic table in a while. That's where the critical or the REEs exist, and it is a challenge. We know it's rarer in the sense it's actually the challenge of extracting those. And of course, some of those green elements there that you see are DOI classifications of critical minerals as well. So there's a whole host of minerals. I was actually attending a conference, and you'd be surprised if you were to actually put a flag on every one of these elements as to where they belong. China definitely predominates, and that's the story again today. And that's why we're at the crossroads. It's a lack of investment, foresight. You can talk about a lot of different things, but we also talked about the investment in mining. We were lacking in investing sufficiently in the mining space as a country, and making that a national priority. Just another perspective of, this is a DOE criticality matrix, as it's called. And you can see lots of elements in there, but what's interesting is when you looked at that criticality mineral, the graph on the right is for the short-term perspective, where you're looking at 2020 to 2025. And then you look at the medium term, which is the next 10 years after that. And you can see how these minerals are moving over to the right in terms of supply risk, and then moving up in terms of importance to multiple sectors. It's designated as energy, but you can see a lot of the elements that we're talking about represented in this matrix here. So, and then on the right-hand side is just a general perspective on how critical this is to our defense systems, and how much of the rare earths elements are required in those various aspects of, from fighter jets to submarines. You're looking at 2,300 pounds or more of rare earth elements required for submarines or so. So back to technical studies, that's what I was asked to talk about and why it's necessary. As I mentioned, if you're a publicly listed company, you're absolutely required to report on the stock exchange. And that report you file, which may be a PFS or an FS, is available to you and me as the public. It's supposed to be there for us to evaluate our investment and see how, again, feasibility of that. What do the investments look like? What's capital investment? What's the return on your investment? Because we are the active investors in this company's stock. If you are a private entity requiring private equity financing, the same thing applies. They are going to ask you, the first question they're going to ask you is, where is your PFS or an FS? And the level of financing dictates the level of detail that goes into this. And by default, even if you go to the private financing group now, they are going to ask you to present a report that conforms to a standard, international standard. The SK is our SEC requirement. NI 43-101 is the Canadian standards. JORC is the Australian requirement. PERC is Europe. SAMREC is South Africa. All of them pretty much follow the same guidelines. You can't take a shortcut with one of them, but if you're listed on one of these countries' stock exchange, you have no choice. You have to follow those guidelines. And they all have minimum disclosure requirements, including the environmental and social components, which have become increasingly important, as we all know. And so we have to, and we talked about that, and it's the whole perception thing, the license to operate aspect of it. So we need the social buy-ins. We've got to demonstrate that our projects are environmentally responsible, sound, and that we're engaging all the stakeholders in this venture that we're embarking on. A lot of words on here, but the key things to focus on, and again, these are common themes in all these disclosures, is transparency. You've got to be transparent to the investor. You and I are fully empowered to ask these companies for what they're about to do. Materiality, every aspect, every material aspect of the project has to be disclosed, and competence, and that's a key requirement here as well. That report or reports or sections of the report have to be completed by responsible, qualified persons or competent persons, and that typically requires you to be licensed in the country and or the states, a PE, a PN, those kinds of things, certain years of work requirements, knowledge of the commodity that you're working in, knowledge of the type of mining. Is it surface? Is it underground? Do you have the appropriate experience for that as well? Just to give you an example, this particular project kind of rings close because as part of my experience, I actually lived in Indonesia and I managed an office there working with the mining companies. I spent 90% of my time on the road at the companies. The year I went there in 1997, has anybody here heard of BRIEX? Perfect. Has anybody seen the movie Gold with Matthew McConaughey? There you go. So, but that's what this is all about. 1997, I actually lived in the city where the lab that was involved in the scandal was located. As you can see from there, the stock market price, it was on the Canadian Stock Exchange, skyrocketed from what I believe was a couple of cents to, as you can see there, $268 Canadian per share, and then it cratered from there. And what's also interesting is if you look at the the names involved in getting into, actively getting into this. I mean, you're looking at Fidelity Investments. You're looking at major players like Barrick and Freeport, right? I mean, these are experienced guys. They know what's going on. Yet at that time, J.P. Morgan brokers trying to sell the stock. And it all cratered because the samples were being salted in the lab in Indonesia, right? So there was no chain of custody. Nobody was responsible, yet they were putting out these reports. And that's part of the reason for the disclosure standards, to protect all of us as investors, to protect others as investors, the private investors as well. So, it's just a great example of why we need these studies and the standards required of those studies. Very quickly going over, I know I've got a lot of slides. I want to make sure I give enough time for us, but this is kind of the classic approach to a mining life cycle, right? We've got exploration, the resource estimation, then you go into reserves, you do your detailed engineering, and then you go into construction. And with each of those, you can see a particular type of study that is typically associated, the scoping study or a preliminary economic analysis, and that's what the PEA stands for. And then you have the PFSs, the feasibility studies, and then, of course, the construction stage of it. Now, I would like to argue that the feasibility study, it's not just a one stage. There are several stages of refinement as you do the feasibility study as well to get to a more detailed estimate of both the technical and commercial aspects of the project. And rather than looking at it sequentially, I mean, I think we all know innately that this is a circular sort of iterative process. You do not end at one. For example, you do your exploration, you do your resource estimation, and then you do more exploration, and say the lab results come back and the process recoveries are different now, right? So you go back and reestablish what your resource looks like. The economics, if it may take a year between your first exploration and the next exploration, what has happened to the markets? That price of that commodity, again, dictates what's going to happen. If the price drops half, your reserves are not going to stay the same. Your investors need to know that. That, again, is a reason for us as responsible people in this industry, as perhaps QPs, one day QPs, CPs, of which I am one, and I'm sure several of the people sitting here are as well. We owe it to ourselves, to our industry, and to the investors that this is done according to standard. This is just a risk profile. I mean, it's out of our SME mining handbook, but kind of shows you how, the solid line is where we increase project value as we go through the various stages and various process of studies. And then where you de-risk it, that's the dotted line where you're decreasing the investment risk as you go through. But again, you can see that it's ramping up, that risk initially is ramping up, right, until about the point you've completed the construction, and into production. So again, with the pre-feasibility and feasibility studies driving that, you have a little bump in the risk towards the end. As you can see, that's your final closure. Just repeating this slide because and as you can see in red, one of the biggest risks we see happening over and over again is, especially with smaller companies, the juniors, they want to skip. It's taking too long. They'd like to get their investment back as soon as possible. So let's skip the PFS. Go from the PEA to the feasibility study. I can't tell you how many projects have landed in the graveyard because of that. Because either they'll take it out there to market and they run into all kinds of problems. So we have to be methodical. It takes time and money, as I mentioned. That's the other reason people do not want to invest the kind of capital is required to complete the studies. The studies themselves, depending on your project, can cost millions of dollars over these years. So typical risks, again, lots of words on there, but I think these are all obvious to us. The technical risks lie in how the models are created, the metallurgical processing, which is huge, especially when it comes to rare earths. The equipment, process, and facilities. How detailed did we get into the engineering design? How detailed did we do our capital estimates? And that's the reason for the PEA, PFS, and FS. You've got to take your time to do this. Your biggest risk in both in terms of technical and capital, most of the time, there's a lot of it that goes into the process plant and facilities as well, which is sometimes ignored. And then, of course, infrastructure, power, water, rail, again, depends on the geographies. I mean, it's different for us in the US as opposed to a project in, let's say, Africa somewhere, in Asia somewhere. So those geographic risks should also be taken into consideration. Environment and social, as we said, that is a big component. We absolutely have to pay attention to it. We've got to get the social license to operate wherever we are. That's a big component of being, getting off the ground with a successful project. Active engagement with the stakeholders, and recognizing that you will face, depending on where you are, there's always opposition to these type of projects, as we've heard in our discussions today. And then, of course, financial, and that's a big part of it. All of it sort of revolves around financial, but we often forget that all these other underlying factors each have a very important part to play in the final capital or the financial assessment of the project. So things that could go wrong, and these, like I said, these apply to most projects, and definitely as we look at the REE landscape right now, underestimation of political risk. A lot of this applies more to other countries out there in the world, but change in administrations, as we've seen, can make decisions different. Tariffs and prices and taxes and all that kind of stuff play a part in this. Underestimation of infrastructure costs is also a huge piece of this. Overestimation of exploration potential, especially with the juniors. They'd like to go as soon as possible from declaring their exploration all the way to a project, and that never actually happens. You still see a lot of that occur in the junior space with some of the stock exchanges, just trying to raise money and kind of for them to cash out. Underestimation of geological risks. Have we drilled and explored the property well enough? Punch 10 holes and walk out of there with a project with a PFS, it's not going to happen. Have you actually explored that correctly? We just saw all the kind of detailed imagery and stuff that we have. Have you considered all the aspects of the project you've got? Poor anticipation of commodity pricing. That's another big risk we have. We go in, like I said, we complete a PFS with a certain commodity price, except it's taken us 3 years now to get, just as an example, to complete our feasibility study, and prices could have changed, and it does change. And then failed communication. We see this as a big piece of the failure to complete the technical aspects of a project properly. It's not just the geologist, it's not just the process engineer, it's not just the mining engineer. Are we talking across the board? Is our model that we are creating, the geologic and mining model, which is the basis of our mine plans and capital and CapEx and OpEx estimates and life of mine plan, et cetera, have all the teams talk to each other? So is this a sound basis for making our decisions? So just a very quick word on the framework here. There are several, like I said, there are lots of companies that or committees. There is the International Committee for Reporting Standards, which is CRISCA. The U.S. is a participant to that, but there are about, I believe, 15 countries involved in here. So all the major players, all the major mining companies, they all have their codes out there. But as I mentioned, they're all pretty similar in their requirements. How you classify mineral resources, how it gets transformed from a resource to a reserve. This is a graphic you will see everywhere. And on the right-hand side is SK 1300, that's CFR 17229. Those are the regulations U.S. companies work under, and that is a regulation. It is not a guideline. The regulations even contain every section that you're supposed to include in your report, for those of you who are familiar with it. So, which I like. And we were late to the game. The U.S. was very late to the game. We started, I think SK came into force in 2021. That's when it became mandatory, when the rest of the world was already there. So this has gone a long way in protecting our industry and protecting the investment community. As I mentioned, strict guidelines, you cannot escape this. So these are the sections that are required in a technical report summary, often referred to as a TRS. The Canadian requirements or the Canadian sections look very similar. That's what I'm saying. They all look, they are very similar in their requirements. So oops, sorry, looks like I've gone too fast here. So these are expensive decisions, as I mentioned, and some of the common challenges I'd like to just lay out there. So this is by McKinsey and Company, which is one of the big consulting firms out there. This is a comment directly from them that many mining executives still rely on the same feasibility study procedures that they did years ago. And as you can see in blue, that's a problem because the projects are becoming larger, more complex, and often more remotely located, making them more susceptible to cost overruns, which is something we also see, again, a lot. Just a quick graphic on mining project cost overruns, and this is by McKinsey themselves. Only 20% of projects, as you see at the bottom, actually have incurred no cost overruns. Look at the top, greater than 100% over budget, almost another 20%. Come down one level, you've got almost 45% that are 15 to 100% over the sanctioned budgets. This is the state of affairs for our industry, and it should not be happening. The fact is, many still ignore it and continue to do things the old way. So what are the biggest mining risks? And I think actually during the course of our conversation today, if you look at the top three, ESG, and this is a survey of the industry and of the folks involved in it, you can see ESG being right on top. And what's also interesting is you look at number 3 there, it's license to operate. Those are very critical components for any project to be successful anywhere across the globe, not just in the US. And that's a common theme. Capital, it remains number 2, but as I mentioned, what we often forget is capital is intrinsically tied to every other aspect that we think is not, which includes ESG. Getting the permits, getting the social, stakeholder buy-ins, all that kind of stuff takes time and money. Just another graphic. This is, though it applies to lithium, is another interesting sort of factoid on our industry. If you look at it in North America, for example, early stage projects were 85, and as I put in the box on the right, about 6% of early stage projects reached construction. 5% of early stage projects began operations. That applies to the numbers related to the US, but I'm pretty sure you can get similar comparisons across the globe as well. So this is a perspective on how successful initiatives in the mining industry are. And again, I bring this up with our strategic push now to rare earth minerals projects, which are even more complex. And to give you an understanding of, these are typical metrics, not, don't expect them to be actual, but the fact that, cost of carrying out a study is as important of the project itself. And what the bottom sort of table is telling you is that typically for a $100 million project, you're going to put in about $5 million in studies. That's, just an average estimate. We have a recent example that I'm going to cite here. The estimated capex of the project is $1.5 billion. The PFS was about $2 million. The FS and FEED study, the detailed engineering study, was about $15 million. Small in comparison to the total installed cost of the project, but still substantial when you think of it in sheer numbers. And part of that was, as I popped down there, is power generation, and some of the other studies were conducted in-house, so those are not included in here. So I keep repeating this, that the capital estimates don't stand on their own. Plant cost estimates, the feed grade, the recovery, so therefore the processing performance characteristics. Recovery estimates, require thorough testing from early days PEA, where it's kind of initial lab analysis, then you move on to bench testing, pilot plant, and then demonstration plant tests. With those demonstration plants run continuous testing. Equipment, are the equipment prices that we're including in our studies based on quotes or bids. It makes a huge difference. If you want to get to a FEED study, you've got to put a request out there for bids and undertake a detailed study to get your capital estimate actually right. Was the detailed engineering design done up to standards? One of the points I bring up as well, the last bullet, the tailings studies. It used to be that tailings were just kind of drawn up, more of a civil engineering. There was definitely detail put into it, but I think the recent experiences and failures of tailings storage facilities have led to some deep reviews of it, and therefore I bring up the GISTM standards, which are global standards for designing tailings. And some of the other aspects out there, when we did our models and mine plans, does that incorporate geochemistry, geotechnical, hydrological? All of these have to be considered together, and did we consider geopolitical and geographic risks? Just a very quick visual. The purple line is sort of just very purely just to show examples. That's a resource kind of pick where you've got the measured, indicated, and inferred resource in there, but then you consider prices and economics and geotechnical, and then all of a sudden it becomes the green pit. And just an example, what if price changed, or you made a change to your geotechnical pit design? Well, it then becomes a blue pit. So all of these work in hand with each other. I know I'm getting pretty close here, but so just the costing framework, and this is just for more of a know-how. There are rules or design regulations and expectations out there. So in terms of the methodology that we approach, AACE is a big component. For those who are not aware, that's a costing sort of estimation, not regulatory guidelines, which I think we should all be aware of and utilize when conducting our studies. Just more of the same. And then when you look at the costing requirements, you've got accuracy, what's your contingency. There are actually regulations required in dictating that as well, so make sure we're aware of that. And then in terms of the spread in our estimation, most of us do, let's say we're doing a discounted cash flow, we do a static assessment of the project. More and more, though, we are having to look into Monte Carlo simulations. What is the probability? And that's the question that investment firms are going to ask you. How confident are you in your estimates? And therefore, it's important to run those kind of simulations on everything that we do. REE projects, greenfield projects pose a special challenge. If you're an existing operation, I'm going to use energy fields as an example, and you're then looking at REE processing, it's one thing. But then if you're looking at a completely new greenfield project, that's a completely different challenge. The processing infrastructure all becomes much more of a challenge. The complex and novel processing requirements are some of the largest risks I've seen so far to CapEx and OpEx definitions. And the special permitting requirements are do we have, typically you're going to have radioactive elements in both your waste stream and your ore stream, your tailing stream. So, how do we address that? Do we get the permitting for that taken care of? And as I mentioned, the recent CapEx estimates are getting upwards of close to $1 billion. I was on a call recently of an RE project in the U.S. They're going out to the Exim Bank for financing. That project was quoted at about $780 million. So, and then we're all now striving for limited private capital in the markets. So that's another challenge that faces us. Just potential solutions in a government, and we've talked about this as well, government commitments to RE projects, government funding, new exploration activities, and there's a report out there by the Center for Strategic and International Studies about the creation of RE hubs in countries, and applies to the U.S. as well. I think we were talking about part of it in some of our discussions. And international alliances. The fact is that there are international companies investing in the U.S. Investing in international companies, allies to be able to procure either raw commodities or processed commodities. And so that's part of the overall strategy. And I think we've Continued on our talks about DoD, DOE type financing or funding of domestic projects. Policy restrictions, permitting, taxes, incentives. And at the same time, pricing is always what drives projects. So what do we do about RAE sales pricing in the U.S.? So we will need some clarity around that as well as we move forward with RAE projects. So pretty much, I think I mentioned most of it, but the primary thing, my message would be, if we are to undertake feasibility studies, it has to be rigorous and detailed, demonstrating the feasibility of these projects. We talked about the accuracy in CapEx and OpEx estimates, and the feasibility studies absolutely have to adhere to industry standards. Feasibility studies cannot be rushed. We talk about, I think I may have gone through it very quickly, but typical expectations from PFS to construction and production is about 12 years, again, something by S&P that was put out there. And look at simulations. We cannot have a definitive. As you're thinking about your projects, think about decision tree analysis. Think about what-if scenarios at the PFS level. Take your time, understand what happens if the commodity prices were to change, what happens if there was a geopolitical impact, just like we saw with China and squeezing down on REEs. And that again goes back to the bottom line. Studies do take time and money to get it right. And that's it for me. So thank you for your time. Thank you for all the time. And I'm open to questions if anybody has any.